بسم الله الرحمن الرحيم والصلاة والسلام على نبينا محمد وعلى آله وصحبه أجمعين. Okay, so far we have covered the embedded devices, and we have mentioned that there are two types of embedded devices, including microprocessor and microcontroller. We talked about the different low-level details about their components. And today we will introduce, or we'll talk again about sensors and sensing technologies for the Internet of Things. And you know, sensors are like the core part of the whole IoT ecosystem, because it's the device that will be able to collect the data. And we talked about this, that the role of the sensor is to collect the data. But today we will respond to a particular question, or a fundamental question. How does the sensor work? How a sensor is able to collect the data from the environment? For example, if I take a temperature sensor, how can this sensor, it's at the end a physical device, how it is able to tell me that the current temperature here is 24 degrees or 23 degrees. So there are physical aspects, okay, electronic aspects that we try to understand at high level. Maybe I will present a few equations, physical equations or calculations, but the most important thing is just to introduce you the high level concepts. And I don't want you to see this sensor now. If I show you this sensor, probably you don't know what it is. This is a temperature and humidity sensor. For you now, this is like a black box. It just will collect temperature data, but you don't know how temperature is actually collected, how the heat is actually detected. So I'll try to introduce you this concept to understand what is inside this sensor device and how it works. And during these two lectures, today and next Wednesday, we will go through many of sensing technologies, like temperature today, humidity. We'll talk about pressure sensor, how do they work, range sensors using ultrasonic technology or infrared technology to get the sense of that. So the learning outcome, first of all, we'll introduce the sensor fundamentals, explain the role of sensors in IoT systems, their fundamental operating principles. Also, and this is, you know, the core theory, is the transduction theory. And it's basically the process of converting a physical quantity into an electric signal, because an embedded device, it just deals with digital numbers, okay? And a sensor, it's basically a physical device. It's basically kind of wire or capacity or resistance or anything else. So there is a process where we can convert this physical phenomena into an electric signal. And from there, we can infer the value of this physical phenomena, whether it's humidity or temperature or soil moisture or range sensor or so on. And we will discuss common type of sensors that we will find. So this is the lecture outline: the sensor fundamentals, transduction theory, common sensor types, the characteristics of a sensor, what is signal conditioning, and then we will have two applications: temperature sensors and humidity sensors. So the role of sensors in IoT, we already talked about this many times. It's a sensor device detect and measure a physical phenomena, okay, and converts it to an electrical signal. And sensors act as like the eye and ears. They can see, they can observe, they can sense any event around the environment, and then they can communicate this event into in real time through the internet, to make decision-making, automation, or data analytics. I hope you remember all the different discussion we've talked about IoT applications like Industry 4.0, cyber physical systems, robotics, and so on. So when you build your IoT application, it's important to carefully select your sensor. So choosing the right sensor can make or break an IoT application. And the key considerations are accuracy, precision, range, and communication interfaces. This is very important. There are many sensors that you can find in the market. Let's say, for example, a range sensor, laser scanner. You can buy a laser scanner with $100 or probably with $20,000. And they calculate the range. But one of them, maybe, you can find a range sensor of maybe $1. It's just ultrasonic. It gives you 20 centimeters or maybe 1 meter of range maximum. You have some others, they can give you maybe some kilometers of of range. So there is a difference in terms of the design, in terms of the component, in terms of the power. So all of this, in terms of the accuracy also, some of the sensors, they won't give you high accuracy. They have a lot of noise, so probably they are not fit for real-time applications or critical applications. So we need to understand these different characteristics and how to make the proper sensor device selection. And also the system design, understand the sensor fundamentals, is crucial for optimal system performance. So the basic principle of the sensing operation. أول شيء which I'm going to introduce is the concept of transduction, and this is what I want you to understand very carefully, because if you understand this even at high level, you will understand how any other sensor will work, okay, which is converting one form of energy into another. We convert it from a physical phenomena into a digital signal, okay. The central characteristics, what is the meaning of sensitivity, what is the meaning of range, of resolution, of linearity or accuracy. And the electrical interface, we already talked about this, the difference between analog signal, digital signal, and the communication protocols. That was already introduced in the lecture of embedded devices. Okay, this is the most important part now. So what is transduction? So the definition is convert a physical phenomena, for example, heat, light, pressure, into an electrical signal. So give me one sensor or one device that you know that is based on, can convert light into electricity. Solar panels. Okay? فيها cells, photons. يمتصوا الإضاءة. And they convert this into electrical signal. So this is one application. Okay? Some others, sensors, they can convert heat into electricity. So at the end, what every embedded device is going to measure is just maybe a voltage output. And this voltage output is going to be converted into a digital signal. لو تتذكروا ADC. What does it do, the ADC? Analog to digital converter. It takes an analog signal, which is a voltage level, and converts it into a number between, for example, 0 and 1024. If it is over 10 bits, the resolution can depend. Okay, and this is what makes the value that we receive from the sensors, from where we can infer the value of the physical phenomena. So the key component, we have a sensing element, which is usually a material, okay, that detects the physical change. And for example, thermistor for temperature. A thermistor is kind of material. When you apply a temperature, is going to change the resistance of that material. الريزيستنس تتغير. ونعرف أن الفولتج لما يمر على الريزيستنس يعطينا current. قد ما تكون الريزيستنس أعلى، قد ما يأثر على الكرنت، يا إما أكبر أو أصغر. Okay, so the higher the resistance is, the higher the current is. كل الالكتريك ديفايسز كلهم فيهم ريزيستنس من جوا، هذوكم اللي يستهلكوا الطاقة. Okay, that creates the power. So signal conditioning. So usually sensing devices, they can collect very low signals. So these signals sometimes they need to be amplified. Okay, if their magnitude is low, they could be filtered if they have a lot of noise. So all of this we call them conditioning. We'll talk about this. Okay. And this is the process. You have a physical phenomena. Okay. You will receive a sensing element, which is a digital, okay, the sensing element, which is a voltage. And here we make signal conditioning, filtering or amplification. And finally, we will have the electrical output that will allow us to tell what is the value of the physical phenomena, okay, to make an inference out of this. So these are the elements of a transduction process. We have a sensing element. For example, in the case of temperature, we have a thermistor. And the sensing element is the core component of a sensor. It detects the changes of the physical environment, such as temperature, pressure, or light. We have signal conditioning circuit that will make amplification, noise reduction, okay, And we have the output interface, which is the standardized format that can be read or understood by an embedded device. واضح لحد الآن؟ واضح البروسيس؟ Okay. So there are different type of transduction processes that can be achieved. Okay. في عندنا resistive, capacitive, inductive, piezoelectric, optical, Hall effect. Like it seems difficult words, but they are intuitive. Let's try to understand one by one. So the resistive is based on what? Okay, the resistive is based on when you change the physical phenomena, it will have an impact on the resistance. Okay, and this change into converted into a measurable voltage using a simple voltage divider. لما تعمل 5 فولت وتمرريها في high resistance, it will the voltage that can be measured will be lower, يتأثر. Okay, if resistance for example is 0 or you don't have a resistance, you have 5 volts, you will get a 5 volts. But if you have resistance, it's going to decrease, okay, when the resistance will increase. And this is what we call a voltage divider. Okay, so in case here we will have a resistance that will divide the voltage with a certain percentage based on the value of the resistance. And warmer, it means a lower resistance. And colder, it means a higher resistance. وهذا اللي استعملوه في temperature مثلا. And I will show you an example later on. The capacitive here, so the physical phenomena will have an impact on the capacity of the sensor. And when something comes near or touches, okay, for example, here works like a tiny parallel plate. The capacity here is like 2 parallel plates. When you apply physical phenomena here, the electric field will change. So here we can measure the electric field, and here we can measure the resistance. And based on the merged value, we can actually infer the value of the resulting event. Inductive is based on magnetic fields. Okay, use a magnetic field to detect metal. And when the metal object enter the field, they create an electrical changes. نعرفوا أنه الأماكن اللي فيها magnetic interference تتأثر كثير بالمعادن. Okay, فلما يكون هناك معادن موجودة في electrical field, هذا يعمل variation في electrical field value, and then we can detect that there is an issue. هذا مستعملون مثلا في السكيورتي، مستعملون في البوزيشن سانسينج، metal detector اكتشاف المعادن، ممكن يستعملوها في اكتشاف المتفجرات، الألغام. اوكي، فيستعملوا magnetic field على حسب الريفلكشن we can detect whether there is metal or no. يستعملوا في السكيورتي، في الاوتوميشن، proximity sensors and metal detector. هذا بيستعملوهم ايضا في المطارات، يشوفوا هل في معادن موجوده في الحقائب مثلا. اوكي، شفتوا السكيورتي تشيك اللي في المطارات، يستعملوا مثلا هذه الحساسات to detect whether there are dangerous materials. The piezoelectric, how it generates energy? It generates energy with vibration. Okay, when they vibrate, vibration sensor, okay, it's piezoelectric sensor, and when it vibrates, so there are some metals when they vibrate, it generates طاقة. وهذه استعملوها في الآن in different smart cities ولا smart homes ولا smart environments. في بعض الآن ممرات يمشوا عليها الأشخاص تقوم بشحن الكهرباء، وهذه من sustainable energy. موجود هذول في بعض المطارات. في مثلا بعض المطارات الآن يستعملوا دراجات، اوكي، to generate electricity، فممكن تشحن جوالك وانت على الدراجة. فهذوما الآن طرق باستخدام الفايبريشن it can generate energy, it can generate a voltage, and based on this we can detect whether there is a motion ولا اوكي. استعملوا في الميديكال ايميجينج، في الاكسلروميترز، اوكي، for behavior analytics, ultrasonic sensors, forces sensors, motion detection and vibration analysis. لو تتذكروا the topic of سوسة النخيل، okay, so one of the sensors that we have used before, it was a vibration sensor. لأن السوسة لما تقوم بعملية الأكل داخل الشجرة تصدر نوع من الفايبريشن داخل الشجرة. ف we can measure the level of energy that is collected from the vibration sensor, and from there we can say whether it could be that there is a red palm beetle insect inside the palm tree or not. And optical, so we create energy using light. Okay, so the sensor turn light into electricity. هذا ممكن نستعمل مثلا حساسات for day and night. Okay, ممكن you want to activate something or deactivate something based on the light conditions. Solar panels مثلا. Okay, it works. It's an optical sensor, and the whole effect is similar to the inductive. It's based also on a magnetic field to generate electricity. Okay, so this is a summary of the common transduction principles. So in the high-level concept is that there are different types of sensors that can convert a physical phenomena into an electrical signal. And based on this, so we can use, for example, heat, we can use resistance, we can use capacity, we can use vibration, we can use light in order to detect certain external events. مثلا infrared, in which type of category? Infrared sensor. An infrared sensor, where it is placed here? Optical. يعني نعتمد على الانفراريد light. Okay. الهيوميديتي. Okay. الهيوميديتي is capacitive. We will introduce this. الفايبريشن قلنا piezoelectric. Okay. الموشن sensor. If you will design a motion sensor, how can you design it? Huh? Motion. How can you detect motion? You can detect motion using piezoelectric. You know, piezoelectric, it can define accelerations من خلال vibration. Or we can detect motion through optical. Okay, الأوبتيكال الانفراريد لما كيف يعملوا أنظمة المراقبة؟ يعملوا infrared sensors، إذا قطعتها يعمل ريفلكشن فيعطيك energy، في شخص مر في motion صارت. Okay, so there are different ways on how you can detect different type of sensors using different technologies. So another thing that is important to know is the sensor characteristics. And here we introduce the key performance parameters. When you buy a sensor, you must understand its performance. مثلا, this is temperature sensor. Okay? So when you buy it, maybe you have برادات ولا ثلاجات تشتغل -50 ولا -60. It's possible that this sensor doesn't work. Okay? It has only a limited range. Maybe it can measure between, I don't know, 5 degrees and 35 degrees. And above this, it will not have any kind of response. This is what we call the range. Okay, so every sensor will come with a certain range. Okay, you have range sensors. حساسات المسافة، في حساس يعطيك متر، في حساس يعطيك 4 متر، في حساس يعطيك 20 متر، في حساس يعطيك إلى 1000 متر. Okay, so the range, it's another characteristic. So it's a characteristic of the sensor. Another important characteristic is the resolution. So how the resolution is defined? مثلا بعض اللايدرز ولا الليزر سكانرز اللي يشتغلوا بالليزر, their price depends a lot on their resolution. So the resolution, it means the smallest change that can be detected. مثال, resolution of a temperature sensor. ممكن بعض السنسورز they can detect variation half degree. Some others they can have detect a variation of 0.1 degree. And some others maybe they can detect only the variation of 1 degree. يعني يقول لك 26 ولا 27، يقول لك 26 ونص ولا 26.2 أو فاصل 3. ف this is the resolution. Some of the laser scanners, so it's a beam, okay, that can detect obstacles in a certain angle. في ليزرز مثلا مرتبط ب 60 درجة فقط، هذا الفيلد اوف فيو. That's a characteristic. وهذا الفيلد اوف فيو ممكن يكون 180، وبعض الليزرز يشوفوا 360 درجة. لكن شو اللي يختلف؟ الآن أنت أمامي يعني the angle is straight forward. So the angle here is 0. The next angle مثلا it's 10 degrees. So الانجل هذا it's a resolution. Some lasers they can detect a resolution of 1 degree or half a degree ولا 5 degrees. This makes an important difference in terms of the accuracy and the performance of the laser scanner. Does it make sense? Okay, so the resolution مثلا في temperature it's the smallest unit of change. يا اما تكون temperature change ولا degree change ولا it depends on the type of physical phenomena that you would like to collect. The sensitivity is the output change per input change. Okay, مثلا التactile screens. These are what type of sensors?
Sorry.
Tactile screens. الشاشات هذوما التactile اللي هذوما touch sensors يعني it's pressure, it's vibration. Okay, so تشوفوا بعض السكرينز الشاشات سريع الاستجابة، وبعض الشاشات تحتاج تضغط عليها بقوة حتى تستجيب. هذه sensitivity. فأنت الآن this sensor, there is a sensor in the tactile screens that will convert a pressure into an electrical signal that tells is pointing in this direction. واضح؟ this is what you call the sensitivity. نفس الشيء في temperature sensor مثلا. الsensitivity مثلا اوكي كم على مثلا على 1 degree كم سيكون التغيير على الفولتج. ممكن 1 degree ما يأثرش، نحتاج 2 degrees ولا 3 degrees حتى يأثر على sensitivity. The response time is the time to reach 90% of the final value. Okay, when you apply a signal you will get a response. بعض الحساسات سريعة الاستجابة تاخذ وقت قصير جدا، وبعض الحساسات مثلا الهيوميديتي سنسور يمكن ياخذ 2-3 seconds to provide you a response of the change. اوكي، حساس الحرارة مثلا، فمثلا إذا كان عندك حساس حرارة بطيء الاستجابة صار حريق بعد 5 دقائق خبرك والله الحرارة ارتفعت 80 درجة. This is not good. The response time is something very important. The linearity deviation from the ideal straight line response. Okay, this is accuracy and linearity are related to نسبة الخطأ، وأيضا هذا الفرق مع ideal response، لأن بعض الأحيان الاستجابة للphysical phenomena is not perfect. And the accuracy is the closeness to the true value, including all errors. Any sensor in the world, whatever, it will have a certain error. And this error, of course, we need to reduce it to the maximum. Otherwise, it may impact the performance of the application.
Doctor,
Yes.
I didn't understand the linearity.
Linearity. الآن في control systems, when you provide an input, the system is going to react and provide you an output. In ideal systems, so there is a linear relationship between the input that you put and the response. لكن in reality خاصة في مثلا لما يكون السنسور of bad quality, the response is not perfect. فيمكن مثلا الاستجابة هي عبارة عن الاستجابة، طريقة الاستجابة يحتاج مش فقط وقت، لكن the response is not perfect, is not going to give you the right process to get the sensing value. Okay.
So it means like the input must be linear with the output.
It's not the response. The response to the input must be linear to the input. Okay. Yes. So this is summary about the sensor characteristics. And another thing also that is important to know is the signal conditioning, including amplifiers, which boost the weak signals to measurable levels. Okay, لأنه sensing غالبا ينتج عليهم ضعف في ال value of the input of the amplitude. So we boost them, especially if we want to send them to a remote location, and filters to remove unwanted noise from the signal, because every signal microphone مثلا يمكن يلتقط النويز of the environment. وذلك تشوفوا أسعار الميكروفونات تختلف. يقول لك فيه noise cancellation. اسمع لي noise cancellation. There is a filter that will reduce the ambient noise and it will focus on the mainstream voice. Okay, so it will make an isolation of the noise from the real signal, and this is what we call as filters. And the ADC, it's the analog to digital converter. We already talked about this, and the objective is to convert an analog signal, which is the reading of a sensor, into a digital signal, which we will need later on to process the information. Okay. So let's start talking about sensor types and their implementations. And we start by temperature sensor. حساسات الحرارة, they come with different technologies. They can build with different technologies. The first one is the simplest, which we call the thermistor. Okay, and you can think about this as a special resistor that changes with the temperature. So we have two types. NTC is negative. It has a negative response. It means warmer is less resistance. And we have a positive temperature. When warmer is more resistance. So you can have different type of thermistor. هذا مثلا إذا زدنا الحرارة تنقص الريزيستنس, وهذا بالعكس. Okay, and both of them, they have opposite responses. Okay, let's come back. If you have thermocouples, and here the generation of electricity is based on the value of the temperature. Of course, there is a certain physical law, but just don't worry if you don't understand the physics. And here the technology, it's based, we have two metals, and the difference of temperature between the two metals will be responsible of generating the current. And semiconductor also is another technology that can be used to detect temperatures, and also pure metal wire. These are four different technologies. So let's take the simplest technology, which is the thermistor. And this is how it works. Look, you have an input voltage of 5. And let's assume that we have a resistance of 10 kilo ohm here. And you have a thermistor. So this is what actually will be able to detect the temperature value. So this one, let's consider, for example, at 25 degrees, the thermistor will have only 10 kilo ohm. Okay, this one at 25 degrees. So this is going to generate a voltage of 2.5. Now, if you connect this to Arduino, for example, and you get a voltage of 2.5, using, of course, the value from the ADC, you can infer that the temperature is 25. So there are libraries that are going to convert this value into this temperature based on the physical characteristics of this metal, okay, which is captured by this divider, okay, what we call the voltage divider formula. Don't worry about the formulas, but I want you to understand the concept that the response to the heat physical phenomena is going to induce a certain voltage according to some physical property. واضحة المعلومة? Okay. So, and you can see now the impact of the temperature. If you apply 50 degrees here, and later on I will make you a demo with this Arduino, you will see that the voltage is going to decrease. And you will see later on when I apply the Arduino, if we put more temperature, we will have an impact on the voltage that is collected from the controller. Okay. And this is the idea of the thermocouple. Here, the voltage output will be as a factor of the difference between the two metals. مثلا I have metal A, chromal, and the metal B, aluminium, okay, and they will be connected. So the difference of temperature between these two is going to induce a voltage, and from there we can also measure the temperature value. And these are different type of sensors that you can find in the market. Okay, this is NTC and PTC, and you can see the response. So for the NTC, the resistance is going to decrease when the temperature will increase, and the PTC, it will have the opposite effect. So the temperature will increase with the resistance. This is an example of semiconductor temperature sensor, and this is an example of thermocouple sensor.
What's the use of the thermocouple?
Yeah, all of them for temperature, but they use different technology.
Okay.
Of course, this will impact in terms of the accuracy, in terms of the response time, in terms of the linearity. Okay, every type of sensor will have a different type of characteristics. So now, based on your IoT application, you can look at the data sheet of the temperature sensor, and based on this, okay, so there are some sensors that, for example, I think one of these sensors, it has good response to very hot temperature, above 100. Doesn't function below 100 degrees. It functions between hundreds and 1000, for example. هذا بيستعملوه مثلا في الأفران ولا في الأشياء اللي يحتاجوا فيها high quality sensors to measure hot conditions, very hot conditions. Okay. But of course, we have different technologies because every technologies provide you certain characteristics of the type of temperature. غالبا هذوما low cost, they can measure these ambient temperatures quite fine. But for industrial level, we need different type of technologies like semiconductor or others. Okay, so this is just the summary of the different things that I've presented, a visual summary. You can look at this later.
But we don't need to understand formulas, right?
No, and I present the formulas just for completeness. But the most important thing, I want you to understand that when you see a sensor, you know that there is certain physical phenomena, okay, that will be converted into an electrical signal. And based on this, we can understand the value of the sensor and take proper actions. Okay, I don't want you to see the sensor as a black box. You don't know how it works internally. Okay. Of course, if we need to explain this formula, I need a full course to go into every single physical detail and map it to the initial physics concepts and so on. But this is not the scope of this lecture. Okay. But this formula just captures the physical characteristics of these metals and how they respond to an external event. Okay. So the humidity sensor, now this one doesn't work with resistance. This is a capacitive sensor. So we have a capacity that will change when there is a wet condition or a dry condition. فهو يفرق لنا ما بين الرطوبة إذا كان جاف ولا رطب. هذا نستعمله مثلا لقياس الرطوبة في الجو أو في مجال الزراعة أو غيرها اللي تحتاج قياس رطوبة معينة. مثلا الناس مثلا يقوموا بتربية الدواجن وإنتاج الدواجن. في مثلا لازم عند ترقيد البيض مثلا يحتاج درجة حرارة 38 ويحتاج درجة رطوبة. في درجة رطوبة مثلا في 18 اليوم الأولى، وفي درجة رطوبة معينة زي ما تكون متوفرة في 3 أيام الأخيرة بالنسبة مثلا لإنتاج البيض. فيجب تعديل الرطوبة بحيث أنه تساهم في تحسين عملية الإنتاج. لو مثلا 3 أيام الأخيرة تخلي بيئة جافة جدا ما يستطيع البيض أنه يفقس. وهذا قد نتكلم على مزارع كبيرة جدا، احنا ينتج بمئات الملايين. فمثلا إذا حسيت تساعد على الكنترول بالنسبة للإنفايرمنت وتحسين الإنتاجية مثلا وما أشبه ذلك. فمثل الهيوميديتي سنسور it's based on electrode with a humidity sensitive dielectric material. And just to make the long story short, okay, we have a capacity here, okay, and this capacity is going to change its characteristics or the frequency, okay, of generation, because here we have a frequency counter. شفت الآن الكاباسيتي هذه على حسب الرطوبة متاع الجو أو جاف، الفريكونسي of this capacity is going to change. What we are going to measure here, we're going to measure the capacity, the frequency. We're not going to measure the voltage this time. So we'll measure the frequency. And based on the frequency هذه تتأثر what we call the water vapor coefficient اللي يكون 80 عند الرطوبة ويكون 1 عند الجو المعتدل. Of course, this is the physical equation, but you know, and this is how it works. Okay, we have a capacitance here. In the dry weather, the capacitance is going to be equal to 1 PF. Okay, and this is going to generate 8,000 hertz. احنا قلنا مش يأثر على frequency of. So the frequency counter, it will read the value of 8,000 hertz. And this 8,000 hertz using a digital to analog converter is going to convert this one into a digital value of 800 اللي احنا قلنا بين 0 و 1024 between 0 and 1024 the ADC 10 bits. So we will convert this into a value, and based on this value we can map. So this corresponds to 0 degree of humidity. Okay, it's the same principle. We start from a physical phenomena is going to affect the behavior of an external device, and based on this we will measure an analog quantity. So the analog quantity that we will measure here is the frequency. فالآن the temperature is based on what? Measuring the resistance, and the humidity is based on measuring the frequency. And all of this is already in this very small sensor. هذا الآن يستخدم resistive sensing. Okay, وعندنا أيضا الcapacitive transduction. فالآن if you apply temperature here or humidity is going to have a response مع resistance والvoltage. Okay, so we have different pins. One pin يعطيني مثلا الvoltage of the temperature, another pin يعطيني frequency of humidity, and based on this we can infer this digital value, and I will show in demonstration just in a while, and we can tell what is the value of the humidity, whether it is 0%, 100%, or something in between. Okay, we have the maximum value from 100 hertz to 8,000 hertz. Of course, this is specific to a particular type of sensor. It may change if we change the sensor characteristic. وشوفوا الآن I connected this device, this analog device, I connected here to an analog pin. Okay, so this is an analog pin because this analog pin is connected to an ADC that will convert it into a digital signal. If I have a digital sensor, I will connect it to these pins اللي هم already digital ما يحتاجوش analog conversion. واضح؟ So this is what I want you to understand. You know, when you take a sensor device or a board like this, you are able to connect correctly with sensors, understand how they works, and later on we will see the programming side, how to manipulate this data coming from these sensors and create our application logic. فأنا الآن last week we have studied the components of this board. Today we are studying the components of this sensor and connect between them. Today I will show you how we can program this embedded board to read this information. وطبعا from now until the end of the course, how to collect this information onto a computer, how to send it to the internet, show it from the database, and complete the whole loop of an IoT ecosystem. Okay, if you like numerical computation, this is just a more detailed view of this slide. This presents the high-level details. This is more details about starting from the capacitance calculation, and then, you know, this is an application in case of a dry environment, how we can get as a value of the PF. This is the capacitance, and based on this, we can induce, according to a certain formula, the value of the frequency, and based on the value of the frequency, this will be converted into a voltage, and based on the voltage, it will be converted to a humidity pack. Okay, so there are libraries that will do all these calculations based on the raw value received from the sensor. And now, for example, for Arduino, you will find two different types of humidity and temperature integrated sensor. This one is the DHT11, and there is also the DHT22. So if we look at the specification, for example, this one, شوفوا الآن نتكلموا على الرينج الآن. تشتري سنسور. السنسور هذا مثل اللي عندي can detect humidity between 20% and 80%. But this is a limitation. Okay, If we want to see very dry values or very wet values, this is limited. And it has 5% of errors. Okay, this one from 0% to 100% and 2% error. واضح? So both of them are sensors. For humidity, they use probably the same technology, but their accuracy and characteristic is different. This one measures the value 0 degree to 50 degrees. And this one can go to minus 40 degrees to 80 degrees. So you can see it's a huge difference. The resolution is different. Okay. So here 0.1% the minimum change it can detect. هذا يعطينا مثلا يقول لك 20.1 ولا 0.01 for the humidity value. This one is only 1%. 2 floating point, and here even 3 floating point, and 0.1 degree here and 1 degree here difference. So this is good for hobby project, basic monitoring, just for learning, and this is for more industrial monitoring and professional applications. And this is how we connect it. Okay, you have an Arduino board. You have a sensor. It can be DHT22 or 11. So this one, it comes directly with a simple connection. But so here, based on the pins, you will have a pin that will connect to the 5 volts, another one to the ground, just to provide power to the sensor, because the sensor has to be powered with 5 volts. And then you have a data link to collect the data from this one. Okay, and this is another diagram. So you have, for example, here port 2, okay, is for the data link, and here we connect it to the 5 volts, and here we connect it to the GNT. If you will buy Arduino, I highly recommend that you buy this shield, okay, and with these connectors. يسهل عملية الconnection. ممكن you can do this directly on these pins. You have to look at the values over here and identify the 5 volts, identify the ground, and identify the analog input, and put every pin in the right place. Okay, but with this connection, it's pretty much simple, so you will focus more on developing your application rather than on caring about these low-level details. And look here, pin 3 is not used. And this is why some sensors, they come with 3 pins, and some other sensors, they can come with 4 pins. And this is the Arduino code. Okay, look now. We connected this pin into the second one. So here we define the DHP pin is equal to 2. And the type is DHT22. So here, this is not complete. In principle, I make include DHT.h, the library. And then we have a function. We define a DHT object connected to these pins, the pin for the humidity. And then we can use read humidity and read temperature. So there is a library that provides us these high-level functions. And finally, you can print it and see this into the console. And now it's time for practice. I'm going to make live demos. But let me first introduce these live demos into the slide. So this is the setup, the same that I have here. Okay. And the first code is just the same as I have shown to you. We're going to read the value of the humidity and the temperature after connecting here. So here we connect to a serial port. This is the baud rate, if you remember. Okay, the speed of sending the data. So we will have 9,600 bits per second. And finally, we will show these values using serial.println and the visualization. The second code that I will illustrate, it's more technical and details. If you remember, during all the lecture, I talked about the transduction theory, which is converting the analog, which is converting the physical phenomena into analog and digital. So now this high-level library in this slide, it will only show us the final value of humidity and temperature. But if I want to see the voltage and the raw values, so it's this code here. Look, here I collect the temperature, the humidity, and then I can read the analog voltage by applying the raw ADC value, which is obtained from analog read. So this one is going to read the analog value and converted. So this is the raw digital value. we will take it from this pin. And then using the conversion, this is the resolution of the ADC. And multiplied by 5, it's 5 volt. And here we will have certain voltage. And you will see how the voltage will be impacted by the value of the humidity and the temperature. And of course, all the magic is done into this library, dht.h. It's the library that will take these raw values and will convert it according to the physical equations that I have introduced in order to get this, the final temperature and the final humidity. فهمتوا علاش I introduced these equations? These equations are being used in these Arduino libraries, okay? And they will help to convert these raw values into read temperature and read humidity. So it's basically it's physical equations implemented here, coded, that will provide you a high-level interface. You don't need to deal with to do this computation on your own. If you want to do them, you can, just applying this formula. But otherwise, they are already implemented into these libraries. And finally, they will provide you the raw values. Let me make the test. Okay, so I will connect the sensor here. So let me allow. Okay, look now. This is connected on the pin A2. Okay, if I don't put the right pin here, you cannot read. So you need to make sure that you connect your device into the right pin and then put the same number. Of course, this is a library that will be responsible of doing the whole magic, converting these analog digital values into the real values of the temperature based on the calibration of the sensor that was done and the response of the material inside. Of course, this DHT library, I have already installed it from include library. So if you want to install any library, and when you buy any sensor, it will tell you which library and how to install it. So there is no a miracle. Just let me check. Okay, so here we connect to the serial port because I connected the device to the serial port of the microcontroller. And this is a message that we will print. We will collect the values every 2 seconds. So after collecting a value, it will sleep 2.5 seconds here. So we read the value of the humidity, we read the value of the temperature, and then we check if the values are not null. We will, if they are null, we're going to say failed to read the sensors. Otherwise, we will print these values. Very simple code. Does it make sense?
Yes.
Okay. So now just we upload this one, and basically this is the same IDE that you use to upload the code into the firmware. So here we're going to upload it into the firmware of the embedded device, which is in the EEPROM. Okay, so it can last there. It's not erasable. And now I'm going to upload this. No board is selected. Okay, yes. So first of all, I need to select the board, which is the serial. Okay, look. Board manager. I select the port. The board is Arduino. In principle, it should detect Arduino Uno, because there are different types of boards. So you need to tell the editor which board we will compile for. Now it's compiling. Now this has converted this C code into a binary. And now I will upload the binary. I will upload the binary here. Now it's uploaded. So how do I know that it is collecting? So here, in order to visualize this println, so look, we send them to the serial port. So here we have a serial monitor. Serial monitor. And this serial monitor, it will show us the value collected every 2.5 seconds. Now the current temperature is 22 degrees, makes sense, it's air conditioned, and the humidity is 35. Okay, maybe if I put my hand here, and you can check what happens after, whether there is a variation. Okay, look, the humidity is a bit less. Okay, it starts to be hotter. Put my hand here, 22, 24, so you can see the change. 25, 26, and so on. So it's responding. And now let's try the second code, which will show us more details. Okay, I want to show. Select a board. I selected the board, this one. So it compiled. And look now, I will do the same thing, but I will read the analog device value, the temperature and humidity based on the DHT library. It will do the conversion. And I will also collect the raw ADC value, and also the analog and the digital value. So this is the digital value, and this is the analog voltage value. Okay, let's try to upload. Now look. (26) we have. Let me stop it for a while to be able to read. So binary representation, this is the value that we get from the ADC, the analog to digital converter. It's a binary, and this binary we can convert it to decimal. So this will make this represent a value of 726, which is a value between 0 and 1023, and this corresponds to a voltage 3.5. The 5 corresponds to 1000, and based on this equation, okay, 5 volt divided by 1023, the scale of the resolution, so this will represent 3.548. And these two, they corresponds to a temperature of 26, okay, and the humidity is 33. اكتشفت الاشياء النظريه الموجوده, it's already there in the embedded system. Okay, you have seen the effect of an ADC. You can see the impact of the temperature on the voltage. Okay, so if the value of the temperature changes, look now, there is a small change here, but it didn't affect the value of the temperature. It's 26 here and 26 here, because this one has a resolution of 1 degree. So it's not sensitive to these small changes. واضحة الفكرة? This is how it works. And this concept of sensing, it's basically the same with others. Tomorrow we will see some other sensors, or after tomorrow. And it's what the difference is with the physical phenomena and how it is detected. But at the end, any physical phenomena is going to be converted into an analog value, and then we convert it into a digital value, and from here we can manipulate it. Of course, this library, which is the DHT.H, is going to take these digital values and convert them using the physical equations that I have introduced in the lecture and probably were not very well understood, in order for it to get for you the real and the actual temperature value and the humidity value. So there is no magic. واضح? Okay. So with this we come to the end